All right, welcome back. So you've got the plans, you've got all the parts, and now for the really fun part. Today, we're going to take that blueprint and actually transform those individual components into a living, functional bioelectric system. So how do you build a living battery from scratch? I mean, it sounds like something straight out of science fiction, right? But believe it or not, it's totally doable with the right steps and just a bit of precision. Our mission today is simple, really. We're taking some pretty basic components, things you can get your hands on, and we're going to assemble them into a working microbial fuel cell. We are literally bringing a plan on paper to life, creating a device that's just humming with potential. Okay, first up, you know the drill. Preparation is key, but don't think of this as just a shopping list. Think of it more like we're gearing up for a mission. We've got to have our essential toolkit ready to go before we can even think about building. All right, let's look at our building blocks. We've got our anode material, that's going to be the home for our microbes. Then there's the cathode, which is really the engine of the whole reaction. We've got the chamber to hold it all together, some titanium wire to connect everything, adhesives to make it all watertight, and of course, a multimeter to prove that it actually works. See? Every single piece has a job to do. All right, now for what I think is the most important part, forging the electrodes. You can really think of these as the two halves of our bioelectric engine. Getting these right is absolutely crucial for how well our MFC is going to perform. Okay, so what's so cool here is how you can see their different jobs side by side. The anode on the left, that's the foundation. It's the home base where our microbial biofilm is going to set up shop. The cathode, over on the right, that's the powerhouse. It's what drives the oxygen reduction reaction, which is just a fancy way of saying it grabs oxygen from the air to complete the circuit and generate electricity. They're a team, but we have to prep them in totally different ways. Okay, let's dive into the anode first. It's pretty straightforward, but you do need to be careful. We cut our carbon felt to the right size and then we coat it with a graphene solution. Now you might be asking, why graphene? Well, it's because its structure, just one atom thick, gives it this massive surface area and incredible conductivity. It basically turns the anode into a superhighway for electrons, making it super easy for the microbes to dump them off and create a current. After that, we just attach our titanium wire, give it a quick sand to make sure the connection is solid, and boom, our biofilm base is ready to go. All right, onto the cathode, our engine. This part's a little more complex. We start by making this special ink. It's a mix of carbon, an iron catalyst to really kickstart the reaction, and naphthalene, which is this polymer that kind of glues it all together and helps ions move around. We paint this ink onto our carbon mesh. And then comes the really critical step. We treat it with PTFE. Yep, the same stuff in your nonstick pans, and then we bake it. This makes the cathode hydrophobic, or water repellent. Why is that so important? Well, it lets oxygen from the air get in to fuel the reaction, but it stops the water from inside the chamber from leaking out. We attach a wire and our engine is officially forged. Okay, our electrodes are ready. Now they need a home. It's time to construct the chamber. This is the sealed vessel where all that bioelectric magic is about to happen. So we'll cut up our acrylic sheets to make the walls of the box. Then we drill some really precise holes, or ports, for our wires to pass through, and also for adding our microbes later. The key here, and I can't stress this enough, is to seal everything perfectly to make it totally watertight. A leaky chamber is a failed chamber, plain and simple. Now, for some designs, you might add a membrane to separate the two halves. But for this build, we're going to keep things nice and simple. And here we are, the grand finale of the assembly. We've got our electrodes, we've got the chamber, and now it's time for the final integration. This is the moment where all those separate parts we worked on finally become one single unified device. Okay, these last steps are all about precision. First, the anode goes inside the chamber, where it'll be submerged in liquid. The cathode gets positioned on the outside, leaving about a centimeter gap. Then we go nuts with the silicone, sealing up every single port, every wire entry point. Finally, to complete the circuit, we connect an external resistor between the anode and cathode wires. And here is our very first big test. Before we even think about adding microbes, we need to grab our multimeter and check the internal resistance of the system. Our target? We want to see a reading below 100 ohms. If it's higher than that, it's a red flag that we have a bad connection somewhere that we need to go back and fix. This is a super important quality check. So the assembly is done, and now we're at the moment of truth. It's time to test our work and really think about the core principles we've just put into action. All right, time for our final pre-flight checklist. First up, the leak check. Just fill it with plain water and make absolutely sure nothing, not a single drop comes out. We already talked about the resistance check, right? It's got to be under 100 ohms. And finally, hook up that multimeter and see if you're getting any kind of initial voltage reading. Now, if you hit a snag on any of these, don't sweat it. Just start troubleshooting. It's almost always a simple fix, like resealing a connection or touching up some solder on a wire. Okay, so let's just pause for a second. We've gone through all the how-to steps. Let's talk about the why. What are the really core principles we've just put into practice here? So what are the big takeaways from all this? First, how carefully you prepare those electrodes has a direct impact on performance. No shortcuts there. Second, that chamber needs to be inert and completely sealed. Third, those strong seals and solid electrical connections, they're not just nice to haves, they are absolutely non-negotiable. And finally, remember that the build itself is the magic step. It's what takes a plan on a piece of paper and transforms it into a device that can actually generate power. And just like that, you have it, a fully assembled microbial fuel cell. It's like a machine just waiting for its ghost. The hardware is done, the system checks out, which of course leads us to the next and maybe most exciting question of all. The system is built. So what microbes are you going to choose to bring it to life?